Hi everyone, thanks for coming. Today I'll be discussing improved data sampling techniques for training neural networks. I'll first talk about mini-batch gradient descent. Then I'll talk about the mini-batch sampling technique that is currently used and its limitation. I'll propose a new mini-batch sampling technique that addresses this limitation. I'll discuss the results and benefits of using this new technique. And finally, I'll present our conclusions and future work. To train neural networks on classification problems for large training datasets, mini-batch gradient descent is typically used. So to explain this, let's say that you have an ImageNet dataset that has over 1 million samples in the training dataset. And let's say you choose a mini-batch size of 32. So you split this large dataset into smaller chunks of size 32. You draw 32 samples, run gradient descent, update the parameters of your neural network, and then keep these samples aside and draw the next 32 samples and iterate. Now, typically, prior to running this mini-batch gradient descent, samples in the training dataset are randomly shuffled, and then mini-batches are picked sequentially. Now, the purpose of this shuffling is to ensure that we don't have samples from a single class that are clustered together. Another way of saying this is that in a mini-batch, we want an even representation from all classes and not have all samples from a single class in a mini-batch. Now, even though this is a desired outcome, in practice, we don't get a perfectly even representation of all classes in a mini-batch. So we propose a new sampling technique in which classes are more evenly represented in a mini-batch. Now, the benefits of this new sampling, the sampling technique that we propose compared to the random sampling technique of the previous slide, is for a given number of training epochs, we get higher accuracy on the training, validation, and test datasets. And conversely, for a given accuracy, we require fewer training epochs, which means we have faster training time. Now, the assumption that we make for the rest of this talk is we are dealing with classification problems in which all classes have the same number of samples in the training dataset.